All right, today we're going to start chapter 15. And it's the beginning of the 10th week. Chapter 15 deals with polynomials and exponents. So, section 1 deals with adding and subtracting polynomials. First off, we have to define what exactly is a polynomial. Polynomial is any equation with one or more terms. A monomial is an equation has one term, because mono means one. For example, 3, 4x to the 5th, negative 7x. All those examples of monomials. A binomial, bi means two. So these are polynomials with two terms. 3x plus 1, or 5x to the 7th minus 3x to the 2nd. It only has two terms. Remember, a term is anything separated by a plus, minus, or equal. Since there's the minus, these are the two terms. A trinomial. Tri means three, so this one has three terms. A quartic is a polynomial with four terms. So you have 1, 2, 3, 4. And anything else, we have different ways of naming those. All right, so basically then, polynomial, poly means many, nomial means numbers or terms. So a polynomial is an equation with many terms. When it comes to adding and subtracting polynomials, we have basically one rule. Combine like terms. Now, when we say terms, we're used to adding 3 plus 5. That equals 8, because they're both like terms. They're just numbers. So what if we had 7x plus 2x? They're common terms because they both have x's. 7 plus 2 is 9x. Or 3x to the 5th plus 9x to the 5th. Since they both have x to the 5th, we add their coefficients. I just introduced another word. There's examples of combining like terms. A term, example of a term, you have 7x. This x is called a variable, and the 7 is called the coefficient. Right, so that's how you read these things. So you have to make sure the variables are identical in order to combine the coefficients. The variables are the same, so we add the coefficients. Now, what rule tells us we can do that? Remember this rule from the beginning of the semester. This is the coefficient. Whatever's in front of the parentheses is the same as the variable. Whatever's in front is the coefficient. Since this is in parentheses and those are inside the parentheses, whatever's in front is the coefficient. So this is the coefficient. And this is the argument, the inside. What this is it's called a distributive property. We talked about this at the beginning of the semester. The distributive property multiplies the coefficient to each term inside the parentheses. So the reason it's multiplied is because there's no plus between the a and the parentheses. There's no plus, there's no minus, there's no division. So since there's nothing there, we know it's multiplied. It's a times this. So a goes to multiply each of the terms. So a times x is ax. Positive times positive is positive. A times y is ay. Okay, so that's the distributive property. But going the other way, that's the distributive. But going with what we call factoring. What do ax and ay have in common? They both have an a. So if you take out what they have in common, whatever's left goes inside the parentheses. So take out the a, you have x plus y. This is the rule we're using. If we have 7x plus 2x, what do both of these have in common? The x. So if you remove the x, you have 7 plus 2. 7 plus 2 is 9x. And you always write the number, then the variable. It's always written in that order. The coefficient goes first. All right, so let's add two binomials together. 3x plus 5 plus 7x plus 3. We have two separate binomials there. Order of operations. Can we do anything inside the parentheses? No. Since we can't do anything inside the parentheses, we have to get rid of the parentheses. What are the coefficients? If no coefficient, then it is a 1. So both of these have a invisible 1 in front. So 1 times 3 is 3x. Positive times positive is positive. 1 times 5 is 5. Positive times positive is positive. 1 times 7 is 7. X. Positive, positive is positive. 1 times 3 is 3. Whenever you remove parentheses, always combine like terms next. Always combine like terms. So once we get rid of the parentheses, we combine like terms. So because of the commutative property, we have an x is there, x there. Because of the commutative, we can move them around. So I move this one with the sign in front of it. I move it behind the 3x. So it's 3x plus 7x. So it's this one moves back, and there's that one. Because you have to have a sign, an operation in front of it. It tells me what to do. Now we combine like terms. 3x plus 7x is 10x. 5 plus 3 is 8. And there's your answer. Can't go any further. All right, let's look at even a bigger one. Let's do some trinomials and trinomials. So we have negative, no. Let's say 7x squared plus 4x plus 2, since we're adding polynomials. 9x squared plus x plus 5 . We'll do bigger ones and then more of them in a minute. So here are the steps. Distribute any coefficient to inside the parentheses. In other words, well, actually, before that, first thing we're always supposed to check is step 0. Can you do anything inside the parentheses? In other words, can you combine like terms inside the parentheses? If not, then we have to get rid of the parentheses. Are there any coefficients? Any obvious ones, like if there was a 5 or a 7 or a 2? Remember, if no number exists, then it is a 1. So both of these have a 1 in front of them. So I distribute. Positive, positive is positive. 1 times 7 is 7, x squared. Positive times positive is positive. 1 times 4 is 4x. Positive times positive is positive. 1 times 2 is 2. Positive times positive is positive. 1 times 9 is 9, x squared. Positive times positive is positive. 1 times, if there's nothing in there, it's always a 1. 1 times 1 is 1, x. Positive times positive is positive. 1 times 5 is 5. Okay, now distribute any coefficient inside there, and then combine like terms. So we have a x squared here, and we have an x squared here. So we have 7x squared and a positive 9x squared there. Here's an x. So we have a positive 4x and a positive 1x. Then the constants. We have a positive 2 and a positive 5. So how many x squares do we have? We have 7 plus 9. We have 16 x squared. How many x's do we have next? We have 4 and then 1 more. So we have positive 5 x's. And then constants, we have positive 2, positive 5 makes it a positive 7. So there's our combined like terms. Okay, let's look at an example. We have coefficients to distribute. Here's an example. We have 3 sets of polynomials. Here's one big one. There's a plus, a minus. There's another one. There's plus 1. So we have 3 terms in this equation. First thing, check. Can we do anything inside the parentheses? That has x. If they have different exponents, then we can't combine them because they're not like terms. That's an x squared. That's an x. This is no x, so I can't combine anything. This is x to the 4th, 3rd, 2nd. That's a 1 and nothing. So we can't do anything inside the parentheses. So let's get rid of the parentheses by distributing whatever's in front. So positive times positive is positive. 2 times 5 is 10. X to the 4th. Positive times positive is positive. 2 times 3 is 6. X cubed. Positive times positive is positive. 2 times 5 is 10. X squares. Positive times positive is positive. 2 times 7 is 14. X. Positive times positive is positive. 2 times 2 is 4. No x there. You notice how inside there we have the highest exponent, 4, 3, 2, there's 1, nothing. You always want to do that first. That way it's easier to see what you have. So always rearrange your exponents from the highest to the lowest. All polynomials should be written that way. The next one. Positive times positive is a positive. Remember, there's nothing in front of it, so there's a 1. 3 times 1 is 3, x squared. Positive times positive is positive. 3 times 4 is 12, and that's x. Positive times positive is positive. 3 times 7 is 21. That's all for that one, plus 2x. So we got rid of the parentheses, which means now we have to combine like terms. So let's look at all these. Any more x4s? No. So our first number is 10x to the 4th. That one's finished, so block it off. The next one, that's for, have a look at thirds. Here's an x to the third. Are there any more x to the thirds? No. So my next number in my sequence is 6x to the third, and that one's done. Okay, now let's have a look for twos. There's one there. There's one there. So I have positive 10x squared, and then positive 3x squared. I can get rid of those. Now, since they're x, I look for only one x. So I have positive 14x, positive 12x, and a positive 2x. So I cross out those. I do that so I know which ones I've used already. So here's 4, 3, 2, 2, 1, 1, 1. So left, whatever I have left should be just numbers. Yeah, I have a positive 4 and a positive 21. I rearrange them so I have combining like terms. There's only one of these, so it's 10x to the 4th. There's only one of these, that's 6x to the cubed. I have two of these, so they're both positive. 10 plus 3 is 13. It's positive 13x squared. I have 1, 2, 3 of those. See, that's these already. I have 1, 2, 3 of those. So they're all x's. They're all positive, so the answer is positive. 14 plus 12 is 26. 26 plus 2 is 28. So it's 28x. And both of these are positive, so the answer is positive. 21 plus 4 is 25. There's my answer. Okay. So that's adding polynomials. Now we're going to subtract polynomials. Subtract polynomials. Okay, so we're used to the distributive property. That's a times x is ax. Positive and positive is positive. A times y is ay. But what if a was negative? Remember, I always tell you, always separate the signs from the numbers. So when I multiply these first terms, negative times positive is negative. A times x is ax. Negative times positive is negative. A times y is ay. So what a negative does in front of a parenthesis is it, when you finish multiplying it, it changes all those signs inside there. Because it used to be positive x, positive y, now it's negative x, negative y. So what if I had x minus y? Again, signs and numbers differently. Negative times positive is a negative. A times x is ax. Negative times negative is a positive. A times y is ay. Right, so let's look at examples. So basically the rule is this. Rule of signs. If the sign, when you're multiplying them, if the signs are the same, they become a positive. If the signs are different, they become a negative. That's the rule of multiplying signs. Negative times positive is a negative. Negative times negative, they're both the same, it becomes a positive. You can only have one sign between any two terms. Here's the first example. Okay, we can't do anything inside the parentheses, so we have to get rid of the parentheses. Remember, since there's no number in front of it, it's a 1. There's no number in front of this, it's a 1. It's actually a negative 1 because there's a negative sign for it. Now distribute. Positive times positive is positive. 1 times 5 is 5. X. Positive times positive is positive. 1 times 7 is 7. Negative times positive, opposite signs, is negative. 1 times 3 is 3x. Negative times positive is negative. 1 times 2 is 2. We got rid of the parentheses, so now we combine like terms. There's a highest exponent is just 1x. Here's another one of those 1x. So I have to move the negative 3x. So I move those two together. Then I have a positive 7 and a negative 2. Combine like terms. 5 minus 3 is 2 x's. Positive, negative. Remember, if you have different signs, take the sign of the larger, so it's plus, and subtract them. 7 minus 2 is 5. So there's your answer. Let's look at that one. Again, it doesn't matter how big it is or how small, it's going to follow the same rules. So negative 2 times 3x squared minus 5x plus 4 plus 3 times negative 4x squared plus 3x minus 2 minus 3 times x plus 1. We can't do anything inside the parentheses, so we have to get rid of the parentheses. Negative times positive is a negative. 2 times 3 is 6 x squared. Negative times negative is a positive, same signs. 2 times 5 is 10 x. Negative times positive is negative. 2 times 4 is 8. It sounds like a lot of writing and moving, but if you separate the signs and the numbers, you will decrease the amount of sign mistakes you'll have in your final answer. It's just when you try to combine everything at one time, you just get confused. That's it for the first one. Positive times negative is a negative. 3 times 4 is 12, x squared. Positive times positive is a positive. 3 times 3 is 9, x. Positive times negative is a negative. 3 times 2 is 6. That's it for that one. Negative times positive is negative. 3 times, remember, if there's no number in front of the x, it's a 1. So 3 times 1 is 3, x. Negative times positive is a negative. 3 times 1 is 3. So we got rid of the parentheses, which means now we combine like terms. So looking at this, the largest exponent is 2. So let's combine those two. We have a negative 6x squared. And we have a negative 12x squared. So that takes care of both of those in my original equation. That means now I'm looking just for x's. Here's a positive 10x, positive 9x, negative 3x. That takes care of all the x's. Then we have negative 8, negative 6, negative 3. So I combine them all in their own groups. So let's look at the first one. Negative and negative, they're both negative, so the answer is negative. 6 plus 12 is 18, x squared, so that takes care of both of those. Here for the x's, you have a positive and a positive, that means it's positive. 10 plus 9 is 19 x's. That takes care of, oh, and a minus 3 x. So negative 18x squared comes down here. Positive and negative, the different signs. So I take the sign of the larger number is 19. It's positive. So 19 minus 3 is 16x. So it takes care of those. Then I have 3 numbers left. Negative, they're all negatives, so the answer is negative. 8, so add the numbers now. 8 plus 6 is 14. 14 plus 3 is 17. And here's my answer. Okay, that's adding and subtracting polynomials. So whenever you add and subtract, write that down in the next one. Okay, there. Whenever you add or subtract polynomials, you only change the coefficients. So whenever you add and subtract polynomials, you only change the coefficient. It's like apples and oranges. If I had 5x squareds and I added 3 more x squares, I now have 5 plus 3 is I have 8x squares. So whenever you add you only change the coefficients. You group them by the term. So let's look at exponents. Exponents, or what people call powers. The exponent is that little number up on top. The number on the bottom is called the base. What does an exponent represent? An exponent represents the number of times you multiply the base to itself. So an exponent is the number of times you multiply the base to itself. Which is why 3 squared, here's the base, that's the exponent. So it says take the base and multiply it to itself 3 times. 3 times 3 is 9, which is why 3 squared is 9. Four to the fifth is 4 times 4 times 4 times 4 times 4. It's some big number. It's not, remember, it's not the same thing as 4 times 5. It's not equal to 20. It's 4 times 4 is 16. 16 times 4 is 64. So, and you keep on going from there. So 4 times 4 is 16. We do 16. 4 times 4 is 16. Then we do 16 times 16. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 1 times 6 is 6. 1 times 1 is 1. Remember, we're supposed to leave a blank space here. 6 plus 0 is 6. 9 plus 6 is 5. Carry the 1. So that's 256 times 4. 6 times 4 is 24. Carry the 2. 4 times 5 is 20, plus 2 is 22. 4 times 2 is 8, plus 2 is 10. So 4 to the fifth is 1024. Yeah, so it makes it a lot easier. Instead of writing that many, just do that. All right, so that's what exponents are about. Ooh, before I go any further, I want to make sure, because remember, it's the base that gets changed. So yeah, we know 2 to the third would be 2 times 2 times 2. It's the base 3 times. 2 times 2 is 4, times 2 is 8. Okay. Is there any difference with these? Well, let's see. So you have parenthesis 2 times parenthesis 2 times parenthesis 2. Is that parenthesis necessary? There's no coefficient, no sign. So it's the same thing. But the difference becomes here. Let's make it square. Is there a difference here? With this one, what it says here, there's a negative, and the exponent goes only on the 2. So the answer is -8. Oh, sorry, twice. I'm sorry, twice. The answer is -4. Sorry, yeah, there's only a 2 up there. So I have -2 times 2. This one says -2 times -2. Negative times negative is a positive. 2 times 2 is 4. So -2 squared equals -4, while -2 squared inside parentheses squared equals +4. Because of order of operations, this negative sign is actually multiplied to 2. This is actually -1 times 2 equals -2. This exponent only belongs to the 2. So in order of operations, we have to do exponents first, or special operations, so it's exponents. So if you do 2 times 2 is 4, and then multiplication. So we have -1 times 4 makes it -4. That's how that works. But this one, since the negative is encapsulated inside the parentheses, it gets carried. So negative times negative, they cancel out. 2 times 2 is 4. So be very careful when you have negative signs and exponents. The exponent, unless it's in parentheses, the exponent only belongs to the number at its base, not the sign in front of it, unless it's inside the parentheses. So negative, open parenthesis, -2, close parenthesis squared. What this one says is, okay, there's a negative sign, it's at the front. The exponent only belongs to its base. The base is directly what's under the 2. So we have a -2 times a -2. Negative times negative is a positive. A positive times a negative is a negative. 2 times 2 is 4. So okay, if there's a negative out in front, then it stays out there, and it is used only at the very end. Okay, so that's the thing about signs. So we know if I gave you x to the 5th, that would be x times x times x times x times x. But it's the exponent tells me how many times the base is multiplied to itself. 5 times. So that's what that means. Let's look at the properties of exponents now. Let's look at the properties of exponents. Remember, the properties are the rules that they have to live by. The first one. If you're multiplying two exponents are two terms that have exponents. As long as they're the same base, you can combine them. Apples and oranges, apples and apples, oranges and oranges. So what this one says is whenever you're multiplying the same bases, you add the exponents. That's the power rule. So let's see what that means. 3 squared times 3 to the 4th. So what 3 squared means is 3 times 3 times 3 to the 4th is 3 times 3 times 3 times 3. So since I have the same number, they're all threes, that's my base. How many times does it occur? 1, 2, 3, 4, 5, 6. It occurs 6 times. Or I could have just since I have the same bases and I'm multiplying them, add the exponents. 2 plus 4 is 6. It's much easier if you do this, because what if I had 2 to the 15 times 2 to the 25th? You're not going to write 15 twos and then 25 twos and add them up. No, what you're going to do, since they're both the same bases, you're going to add the exponents. (25 plus 15 is 40. Okay, so that's the first rule. Whenever you're multiplying the same bases, add the exponents. Whenever you have an exponent raised to a power, then you multiply the exponents. When you have a power to a power, you multiply. For example, what this thing says, there's my exponent. I have to take this 3 squared, I have to do it 4 times. That's it. I have to do it 4, I have to take the base and multiply it 4 times. What does 3 squared mean? 3 times 3. This one, 3 times 3. This one, 3 times 3. And this one, 3 times 3. Since they're all the same bases, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8. I could have done it like this, or by the rule, power to a power, I multiply them. 2 times 4 is 8. So whenever you have a power raised to a power, then you multiply the exponents. Okay, whenever you have different terms inside the parentheses, they're multiplied together. There's no addition and subtraction inside the parentheses. That's a whole different story. That's a lot more work. We'll talk about that later. But whenever you have a product of 2 or more terms raised to a power, that exponent gets distributed to every term inside the parentheses. Okay, let's see what this means. Inside the parentheses, I have two terms multiplied together, 3 times x. That's raised to the power 3. So what that means, I have 3x 3 times, which means 3 times x times 3 times x times 3 times x. By commutative property, I can move them around. Since they're all multiplication, I can move them around. 3 times 3 times 3 times x times x times x. So I have 3s, and there's 3 of those. I have x's, and there's 3 of those. I could have done it that way, or I could just distribute 3 to the third, x to the third. So that's that rule. On a side note, what if my variables had exponents? If I'm distributing, the 3 gets a 3, and then the x squared gets a 3. But we learned in the last rule, whenever you have a power to a power, you multiply. So 2 times 3 is 6. 2 times 3. So you can combine all these rules. All right. The next rule. If you have a fraction raised to a power, like we did earlier, whenever you have anything inside a parenthesis raised to a power, everything inside that parenthesis gets that power. So I distribute that n to both top and bottom. So 2/3, third power. This is the same thing as 2/3 times 2/3 times 2/3. The rule of multiplying fractions is if you can cancel anything top and bottom, do that first. If not, then you multiply. So I have on top, you have 2 times 2 times 2. And on the bottom, you have 3 times 3 times 3, which is the same thing as 2 to the third over 3 to the third. If we had done that here, then distribute it. 2 to the third, 3 to the third. Yes, yes, yes. Of course, something like this, 2 to the third, 2 times 2 is 4, times 2 is 8, 3 times 3 is 9, times 3 is 27. Yeah, if it's something small like that, work it out. But if it was like 2 to the 15th over 3 to the 90th, nah, don't waste your time with it. So whenever you have a parenthesis underneath it, then you distribute inside there. Again, if I had 2x squared over 3y to the fifth, and I raise those to the third. Again, everything inside the parentheses gets that exponent. So we have 2 to the third. This one has an x squared already, so I'll put that in parentheses. There's a 3. It gets a third. And this one is already an exponent. So if you have a variable that has an exponent, put it in parentheses. Two to the third is 2 times 2, we know it's 8. 3 to the third, 3 times 3 is 9, times 3 is 27. X power to a power, you multiply. Power to a power, you multiply. So my answer becomes 8x to the 6th, 27y to the 15th. And there's a final answer. What if I had the same bases in a fraction? If I have the same bases in a fraction, and in this example here, n is bigger than m. So the top number up here is bigger than the bottom number. So if that's the case, then you just subtract them. Remember, they have the same bases, different exponents. 3 to the 5th divided by 3 squared. So on top we have 3 times 3 times 3 times 3 times 3. There's 5 of them. On the bottom, we have 3 times 3. Whenever you divide, you cancel. So we're left with 3 times 3 times 3, which is 3 to the third. Since 5 is bigger on top, it's 5 minus the bottom number. 5 minus 2 is 3. Because whenever you divide, you cancel. Whenever you're canceling, you're removing things. That's why you subtraction. This time, the bottom number is bigger. This number is bigger. So you should always subtract the biggest minus smaller. If it's on the bottom, do it on the bottom. Because I moved this one down here, I have to, there's a 1 in front of there. It stays out in front of it. So you have to make it to a fraction. So we have 3 times 3. 3 times 3 times 3 is 3 times 3. So we cancel. 3 goes into 3 once, 3 goes into 3 once. So what do we have left? We have 1 times 1 is 1. 3 times 3 times 3. 3 to the third. We have these 3. And since the 5's on the bottom, I could subtract the bigger minus the smaller, and there's one on top. 5 minus 2 is 3. So whenever you have the same numbers, same bases, top and bottom, always subtract the bigger minus smaller. Whenever you do that, because that way you'll always end up with a positive number. Let's see what happens. Let's see what happens if we didn't do that. Again, m is still bigger than n. So the bigger numbers down here. What would happen if we did this? So smaller minus bigger. What we're going to end up with is a negative number. So I'm going to do the top number minus the bottom number. 5 is bigger than 2, so it's negative. 5 minus 2 is 3. So whenever you have a bigger number on top and you just leave it that way, what this tells us, if you have a negative answer, if you have a negative exponent, let's see what it should have been. 3 times 3, 3 times 3 times 3 times 3 times 3. Those cancel, so I have 1, 3 to the third. So there's our next rule. If you have a negative exponent, this is right now, that's over 1. If you have a negative exponent, move it to the other side of the dividing line and drop the negative. Because you can never have a negative when you deal with exponents. Your final answer has to be a positive exponent. So since my answer was x to the negative third, I got to flip it over. Take this, move it to the bottom, and drop the negative. So what if I had that? So this has a negative exponent. The 2 stays there. It doesn't have any exponent. And I bring it to the bottom, and I drop the negative. What if I had this? 2 over 3x to the negative third. Here's a negative exponent. I cannot have that. So the coefficients stay where they are. Since this one's on the bottom here, it goes on top, and it drops the negative. All right. So that's what that rule says, is if you have a negative exponent, move it to the other side. And if it's on the bottom, move it to the top. If it's on the top, move it to the bottom and drop the negative. Okay, we know that x squared is x times x. Why? Because rule number one says if I have the same bases and I multiply them together, I add the exponents. That's rule number one. So x squared means I have two x's. If I only have one x, that means it's a 1 there. And there's a 1 there. I have one x. So they're both the same bases, so I add the exponents. Which tells me what, if you have x by itself, that's the same thing as x to the first. Because this tells us how many x's we have. We have one x. And the last rule. X to the power 0. X to the power 0. Anything raised to the power 0 is 1. Anything raised to the power 0. Okay, here's the reason why. Because you have to use the rules we talked about. So let's look at the answer. What equals 1 in mathematics? Okay, besides the number 1, yes. But is there anything else that always equals 1? Yeah, any number divided by itself. 4 divided by 4 is 1. 9 divided by 9 is 1. -3 divided by -3 is 1. So since that's true, I could make it as big as I want it, x to the power n. Now we have a rule that says if you're dividing the same bases, you subtract the exponents. N minus n is 0. So there's the reason why anything to the 0 power equals 1. Okie doke. Which now helps us understand in polynomials, x to the 4th, x to the 3rd, x squared, x. Because what this really means, this one has 4 x's, this one has 3 x's, this one has 2 x's, this one has 1 x, and this one has no x's. So the constant term has a x to the 0 variable. This has 0, 1, 2, 3. So notice how we always set up your equation so it's decreasing in exponents. So the constant term has an x to the 0 power variable. Now let's see how this stuff works in what we're doing. Because remember, we said earlier, whenever you add or subtract, change coefficients. When you multiply or divide, you change the coefficients and you change the exponents. So let's look at multiplications of polynomials. Okay, so we're used to doing this already. If we have a single coefficient on front, positive times positive is positive, 2 times 3 is 6, x squared. Positive times negative is negative, 2 times 4 is 8, has an x. Positive and positive is a positive, 2 times 5 is 10. Let's see what happens now. Now the coefficient is a variable. If it's just x, it has an exponent 1. And the coefficient, since there's nothing there, the coefficient is 1. So positive times positive is positive. 1 times 3 is 3. X to the first times x to the second. Since the same basis, you add the exponents. So now we have 3 x's. We have 2 of them here. One more, so we have 3. Positive times negative is negative. 1 times 4 is 4. X to the first times x to the first, so same basis. 1 plus 1 is 2. Positive times positive is positive. 1 times 5 is 5, and there's only one x. So again, when you multiply or divide polynomials, you change the exponents. I'm going to use the same numbers inside the parentheses, just so we have something the same to look at. So now I have a coefficient and a larger exponent. Positive times positive is positive. 3 times 3 is 9. X to the fourth, x squared. So I have 4 x's here. I have 2 x's there. 4 plus 2, I have 6 x's. Positive times negative is negative. 4 times 3 is 12. I have 4 x's here and 1 x there. So that means I have 5 x's. Positive times positive is positive. 3 times 5 is 15. And I just have x to the fourth. There's no x's here. Let's try it with a negative coefficient. So negative times positive is negative. 2 times 3 is 6. They're same bases, they're both x's. So I have 5 here, plus add 2 more. So I have 7. Negative times negative is a positive. 2 times 4 is 8. I have 5 x's here. I have 1 x there. So 5 plus 1, I have 6 x's. Negative times positive is negative. 2 times 5 is 10. I have 5 x's here. No x's there, so I have 5x's. So that's multiplying by monomials as a coefficient. So if you have monomials, the coefficients and the exponents each have their own place. And you see now, always try to keep the signs and the numbers separately, because it's the bigger these things get, the more negative signs you'll have everywhere. You don't need those mixed up. So treat them all separately. Remember how we distribute. We had this rule here. So whatever's in front multiplies to both terms. That's the distributive property. I never told you what A was. If it was a number, then we know it's 2x plus 2y. If it's a variable, x times x, there's both ones. There's 2 x's, so x squared. X times y is xy. So that's what happens if it's a combination of the both. 2 times 1 is 2, x to the first, x to the first is x to the second. 2 times 1 is positive 2, x times y is xy. So whatever is in front multiplies to everything inside there. So what this one really did was 2x times x plus 2x times y. I took whatever's in front and put it in front of those guys. So x times x is x squared. X times y is xy. What if we had a binomial in front? Remember what we did up here. We had an equation in front. So we take that entire equation and multiply it to each term inside there. So I take this entire equation and multiply it to both of those. X plus y times x. X plus y times y. So I took this x plus y and multiply it to this one first, and then to this one. So now, do it again. X times x is x squared. X times y is xy. Positive, positive is positive. Y times x is the same thing as xy. Yx is the same thing as xy because of commutativity. 3 times 4 is the same thing as 4 times 3. They both equal 12. So y times x is xy. I just put an increase in alphabetical order. And then plus y times y is y squared. You get rid of the parentheses, combine like terms. You have one xy plus another xy. Remember, when you add or subtract, you change the coefficients. 1 plus 1 is 2. Okay, so that's what's going on, is you're taking the first polynomial We're taking the first polynomial and multiplying it to the second. What that means is every term in the first polynomial multiplies to every term in the second. So positive, positive, positive. 2 times 3 is 6. Positive times positive is positive. 2 times x is 2x. So that's this one. He went to both of those. He's finished. Now, positive times positive is positive. X times 3 is 3x. Positive and positive is positive. X times x is x squared. Because there's one x there, there's one x there. So I change, whenever you're multiplying, change the exponents. It's 1 times 1 is 1. X times x is x squared. Combine like terms. 2 plus, this is both positive. 2 plus 3 is 5. Now, since we have variables, always put the largest variable in front and go on down to the constant numbers. This is the final answer. So you take each term from the first parenthesis and multiply it to each term in the second parenthesis. Which you probably remember that from high school, that is called the FOIL technique. It's an acronym for first, outer, inner, last. So we have two binomials, x plus 2, x plus 3. So the first terms in my polynomials, in my binomials, that's my first terms. X times x. There's one x here, one x there. I change the exponents. Whenever you multiply variables, you change exponents. Now the outer ones. So these are the outer ones. Positive and positive is a positive. 3 times x is 3x. Now the inner ones. Positive times positive is positive. 2 times x is 2x. Now the last ones in the terms. Positive and positive is positive. 2 times 3 is 6. And there we have it. Because by these lines, this one's been to both of those, this one's both of those, so it's been distributed. Combine like terms. And there's your answer. And let's do that one. So the first terms. Positive and positive is a positive. 2 times 4 is 8. There's 1x times 1x, so that means there's x squared. When you multiply x's, you change the exponents also. So those are the first ones. Now the outer ones. Positive times positive is a positive. 2 times 5 is 10, and we have 1x. That's the outer. Now we can go inside the parentheses. Now the inner. Negative times positive is negative. 3 times 4 is 12, and there's an x. Now the last terms. Negative times positive is negative. 3 times 5 is 15. So we have 8x squared. You have two x's in the middle. So positive 10, negative 12. 12 is bigger than 10. It's negative. 12 minus 10 is 2 minus 15. And there's your answer. But see, the FOIL technique only works when you have two binomials. Remember, binomial has two terms. If they both have two terms, that's the only time your FOIL technique will work. You can't do a FOIL with this one because all you have a monomial. So if you have a monomial and a polynomial, then it's just distribute. Positive and positive is positive. 3 times 4 is 12. X squared, x squared. So it's 2 plus 2 is x to the 4th. Remember, same basis, add the exponents. Positive times negative is negative. 3 times 5 is 15. I have two x's here and one x there, so that means I have 3 x's total. Positive times negative is negative. 3 times 3 is 9. And I just have two x's as soon as I have any. And I can't combine any further, so I'm done. See, now the FOIL technique will not work here because we don't have two binomials. That's why I like to teach distributivity, because it works no matter what. Distribute everything from this first one to everything in second. So this x has to go to all three of those. This 2 has to go to all three of those. So positive times positive is positive. 1 times 3 is 3. 1x times x squared. I have two x's there and one extra. I have 3 x's. Positive times positive is positive. 1 times 5 is 5. 1x, 1x, so there's 2 x's. Positive times negative is negative. 1 times 4 is 4, and there's only 1x. So that's done for the first one. I got my 3 terms. Now the second one, positive times positive is positive. 2 times 3 is 6, and it's x squared. Positive times positive is a positive. 2 times 5 is 10, and we has an x. Positive times negative is a negative. 2 times 4 is 8. Since I got rid of the parentheses, combine like terms. How many x? That's the only x cubed. So I have a positive 5x squared here, and I have a positive 6x squared there. So that's both of those. Then I have a negative 4x and a positive 10x. That takes care of both of those. And I have a minus 8. So combine like terms. 3x cubed. 5 and 6 are both positive, so the next answer is positive. 5 plus 6 is 11 x squares. I have 10 positive and a negative 4, so 10 is bigger, so the answer is positive. 10 minus 4 is 6. minus 8. And there's your answer. Let's try another one. Let me get a little bit bigger here. So first parenthesis, 2x squared minus 3x. The second parenthesis is 4x to the fifth minus 5x cubed plus 2x minus 3. Notice how even inside the parentheses, I have them so it's decreasing in exponents. So the first one, positive is a positive. 2 times 4 is 8. X, 2 x's and 5 x's, that makes it 7 x's. Positive times negative is negative. 2 times 5 is 10. I have 2 x's here, 3 x's there, so it's 5 x's. Positive times positive is positive. 2 times 2 is 4. There's 2 x's there. There's 1 x there, so 2 plus 1 is 3. Positive times negative is negative. 2 times 3 is 6. And we have x squared. Next part. Negative times positive is negative. 3 times 4 is 12. 1x, 5x, so 5 plus 1 is 6. Negative times negative is a positive. 3 times 5 is 15. I have 3 x's and 1 more, so I have 4 x's. Negative times positive is negative. 3 times 2 is 6. 1x and 1x, so I have 2 x's. Negative times negative is a positive. 3 times 3 is 9. And there's only 1x. Okay, so let's arrange these. So let's see this. We have 2 in the first, 1, 2, and 4. And so we have 2 here, and we have 4 here. If we multiply them, we should have 8 numbers, 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. That's a check to make sure you're in the right direction. So I have 2 numbers in the first parenthesis and 4 numbers in the second. When I multiply them together, 2 times 4, I should have 8 terms. That's before I fix them up. Now I combine like terms. So how many 7s do I have? 8x to the 7s. Is there any 6s? Yes. So it's negative 12x to the 6. Are there any x to the fifths? Right here. Negative 10x to the 5th. There's no more x to the 5ths. How about x to the 4ths? Here's a positive 4x cubed. Oh, no, I need 5, I need 4. Here's a 4. I have a 15x to the 4. Now its next one is thirds. Here's a third. So it's positive 4x to the third. Next one smaller is x squared. Here's an x squared. There's an x squared. Both minus 6x squared minus 6x squared. And then plus 9x. So I have 8, 7, 6, 5, 4, 3, 2, 1. Combine like terms. So it's no more of those. No more of those. No more of the fifths ones. There's only one of those, so it's plus 15x to the fourth. Only one of those, so it's 4x cubes. The x squares, there's two of them. They're both negative, so it's negative. 6 plus 6 is 12. And then plus 9x. And there's your answer. So again, it doesn't matter how big or how small it is. You can get the same answer no matter how you look at it. All right, let me see. So it's just that. Integer exponents and the quotient rule. All right. Integer. Actually, that's the first 3 sections. Let's go ahead and stop there, because chapter 15 only has 6 sections. So we'll stop there for right now. So we talked about adding, subtracting, and multiplying polynomials. That's what we did so far. And then here is still the only things we have left to do are we'll look at next time. We'll talk about special products, integer exponents, and the quotient rule. We went over that already, but we'll do it again. And then the last sections, 15.6 and 15.7, both deal with dividing polynomials. 6 is by monomials, and 7 is with binomials, or let's say, or polynomials in general. All right, so that's it for today. We'll finish up the division parts and the special products next time. All right, everybody, have a great afternoon. Be safe. It's really rainy and roads are terrible. Are there any questions?
No.
Okay. All right, everybody, have a good one. I'll see you on Wednesday.